All right, so today's notes are going to be over one-step equations. Now, here is a disclaimer. Yes, you may be able to solve the equations just by looking at the problem. However, you are going to be required to show work, otherwise your answers will be wrong. So, our goal when we solve for equations is to get the variable by itself. Remember, the variable is the letter. Now, what you see on my screen is an example of an addition equation. So we're going to use inverse operations, which mean the opposite, in order to solve. So what that means is using the opposites. If I see addition, the opposite is going to be subtraction. So our first step when solving is we want to circle the variable, or you can look at it, it's up to you, but I want to see what's happening to the variable. I see that I have addition going on. Okay, now one other thing I forgot to mention, what I want y'all to do is if you see your equal sign, draw a line down to separate your left and right side. This is going to help us organize our work. Now, back to what I was saying. So we see what's happening with our variable is a +7. Step 2 is to determine the inverse. So if I see a +7, the opposite is going to be a -7. Now, I don't do it to just one side, I do it to both. Then I'm going to draw another line to kind of separate it. So our goal with the numbers on the left is to cancel them out. Since a +7 and a -7 are opposites, I cancel. So all that's left on the left side is x. Then I just do 12 minus 7, which gives me 5. So we would say x equals 5. Now step 3 is going to be to solve, which we just did, and check. Here's how we check. Okay, we want to make sure that x does equals 5. So instead of rewriting the variable, if we think x equals 5, we're going to write a 5 in its place. So I'm going to have 5 plus 7 equals 12. 5 plus 7. So now I'll go through and solve like normal. 5 plus 7 gives you 12. So currently I have 12 equals 12. So ask yourself, is this correct? Is it a true statement? It sure is. So this tells us our final answer is going to be x equals 5. All right, now let's look at a subtraction equation. Our goal is still the same, to get the variable by itself. And we're going to use inverse operations, or the opposite, to solve. And the opposite of subtraction is addition. My process is not going to change. I'm still going to draw that line down the middle of the equal sign and look at your variable. I see with my variable, I'm subtracting 7. So in order to solve, I have to do the opposite, which is to add 7 to both sides. The 7's cancel out. I'm left with x equals 4 plus 7 is 11. And I can do step 3 by solving and checking by replacing that variable. So instead of writing x, I can write 11 minus 7 equals 4. 11 minus 7 gives me 4, so 4 does equal 4. All right, so what I want you to do is try these problems on your own, and you'll need to pause the video. But before you pause, let's talk about how these are written. So the two examples I just gave you, the variable was on the left side. Now I see some of these are on the right. That is okay. You can leave them as is, or if you want to rewrite it, okay, you can switch it around and put your variable on the left side. All right, go ahead and try these on your own. All right, so let's take a look at these examples. So if I follow those steps, I see my h, and I'm adding 107, so the opposite would be to subtract. So this cancels out because they're the opposite, so h is just left over. Now I have 103 minus 108. Well, I know this is going to give me a negative because I'm subtracting the smaller number first. So this is going to end up giving me negative 4. All right, the next one. All right, I'm going to circle my variable. I see that I am subtracting 28. So I have to do the opposite, which is to add 28. It cancels out. I have r left over. And then I have negative 50 plus 28. So remember with our negatives, do they have the same sign or are they different? In this case, they are different, so I find the difference. And 50 is technically the bigger number, so I'm going to have negative, and then I subtract 22. All right, and the last one. Decimals do not change the process. So I circle my variable. I see plus 4.5, so I do the opposite, which is subtract. It cancels on the left, so I'm just left over with x. Now, before I even subtract, since I have a decimal, I need to add my decimal, add my 0. And I get x equals 2.5. Now, this is how we have seen it tested on the STAR test before. What value of x makes this equation true? Go ahead and try this one on your own by pausing the video. So you had two ways you could have solved this. You could either go through and solve for x or replace the variable. I personally just end up solving, but I can always check by replacing the variable. So here's x. Now, I see the plus, but there's a negative 100. In this case, don't focus on the plus, focus on the negative 100. So the opposite would be a plus 100. So this cancels. And I see their different signs, so I find the difference. So it's going to be a positive answer, and 100 minus 90 gives me 10. So my answer has to be B. All right, so now we're moving on to multiplication and division equations. So the goal is still the same, to get the variable by itself. And we're going to use our inverse or opposite of multiplication, which is division. Now, once again, process is not changing. I'm still going to draw my line down my equal sign and then circle my variable to see what's happening. Well, rephrase. 3x, when it's written like this, means multiplication. Okay, so when I see this, I see multiplication. The opposite is going to be division. Now, what we are going to do is we're going to use the fraction bar as a division sign and write the 3 underneath. So once again, divided by 3. Now, in the previous slide, or slides, I should say, we canceled things out by having a plus and a minus and it equal to 0. In this situation, our goal is to get the coefficient, which is the number in front of the variable, to 1. So 3 divided by 3 gives me 1. So I can cross these off, and I'm left with just x. There is a 1 located in front of the variable, but we don't write it. Equals 21 divided by 3 gives me 7. So now I can move on to step 3, and let's check it. So I have 3 times 7 equals 21. 3 times 7 is 21. and it does equal 21. It's a true statement, so x equals 7 was correct. All right, now we have division. Once again, goal is to get the variable by itself. We're going to use the inverse or opposite, and the opposite division is multiplication. Now, looking at this equation, this is one way division can be written. It can also be written like this, using the fraction bar. Most of the time, especially later on in math, you're going to see it written using the fraction bar versus the actual division symbol. So once again, process does not change. I'm going to show you the first way first. So I circle my variable. I see I'm dividing by 3. So the opposite is going to be to multiply by 3. And I'm not going to use the x symbol for multiplication since we already have a variable there. So this cancels. I have x equals 2 times 3, which gives me 6. Now the other way we have it written, okay, x divided by 3. I circle my x. I see the 3's being divided, so the opposite is going to be times 3. Except I'm going to write it kind of above next to the x on the left side. This cancels, so I'm left with x equals 6. So both are the same process, just written a little different, and you end up with the same answer. Go ahead and try these problems on your own, and we will check your answers and work with mine. All right, so if you pause the video and completed the 3 problems, this is what you should have gotten for your answers. All right, let's move on. So one-step equations are not about just being given the equation and solving. Sometimes you have to write the equation from the model and then solve, or from word problems. Today we're going to focus on models. Now, very important, how to determine if your model is addition and subtraction or multiplication division. Look at your x's. If I only see one x, this is going to be an example of either addition or subtraction. So what I would write, I see one x, so I write x. And now count how many ones you have. I have 1, 2, 3. So I'm going to, and they're positive, so I'm going to write plus 3 equals 10. Because now I count on the right side, I have 10 positives. And from there, I can go through and solve. Sometimes you have models that are going to have keys. Okay, so you have to look at the keys. So I see that the white circles are going to be positive, the black circles are going to be negative. So if I count on the left side, I have 7 negative, so I would write negative 7 equals. I see 1x, so I know this is going to be multiplication or division, or I'm sorry, addition or subtraction. And I see 3 positive, so I'm going to write plus 3. All right, the next model, a little different. So once again, I see 1x, so I'm going to write x because this is addition or subtraction. Now, I also have 1, 2, 3, 4 negatives. So what I'm going to do is I'm going to write minus 4 and then equals. And then you count on the right. I have 11 negatives, so I'm going to write negative 11. So with this model, we could have written it as x minus 4, or if you prefer addition, you could have written it as x plus negative 4 equals negative 11. I'm going to tell you how I normally write them is like this here. All right, and the last model, okay? I see more than one x, so this tells me, hey, this is multiplication. So since I have 3 x's, I'm going to write 3x. Then I just count the right side, and there are 15 positives. So my equation is 3x equals 15. Now let's take a look at a star question. So it says, which model shows two equal expressions when the value of x is 4? Okay, so what I like to do on this, go ahead and try this on your own. I personally like writing the equations first and then solving, but it's up to you. All right, so hopefully you tried this one on your own. So what I did is I went through and I wrote what the equations were from the model. Then I'm going to go ahead and replace that variable. So it says x is 4. So here, 4 times 4 gives me 16, and I know 16 does not equal 4, so A is out. The next one, replace the variable. 4 times 4 equals 1. So it has 16 equals 1. Well, I know that's not true, so B is out. The next one, I have 4 plus 2 equals 5. Well, I know 4 plus 2 is 6, so that's out. And then the last one, 2 times 4 equals 8. 2 times 4 gives me 8, so that is a true statement, so D would be my answer. All right, so let's talk about our homework assignment for today. You're going to want to head over to Google Classroom underneath week 18 for honors, week 19 for regulars, and level classes, and you're going to click on your Google form. All right, and you have 10 problems, mixed questions that you are needing to solve. Please remember, if you have any questions, there's tutoring available on Mondays and Wednesdays, or reach out to your teacher if you cannot make those times. Y'all have a nice day.